Hello everybody and welcome to my second factoring video in our learning process. In general, when we take a look at trinomials, we look at trinomials basically that are in the form of ax squared plus bx plus c. And for the next couple of sections, we're going to take a look at factoring trinomials that are in this form. This is also known as a quadratic statement. We'll get more into that a little bit later, but just to kind of throw the Q word out, it has to do with the fact that the highest power of the polynomial is squared. But we would like to, in this video, I'm just going to focus on trinomials that are specifically in the form of x squared plus bx plus c. And whenever we're working with a polynomial in general, we take a look at the number that is in front of the variable that happens to be the highest power, and that is what we call the leading coefficient. So in this case, we can easily see that when we are in this form, we are looking at factoring this trinomial. This is a special case when the leading coefficient is 1. So let's go ahead and just kind of get started and kind of lay out what we're going to be doing with this example. So x squared plus 5x plus 6. Okay. And let's also observe that I will be referring to the coefficient involved with the x is denoted as the letter b, and this is pretty universal. And the constant coefficient is referred to by the letter c. Okay, so when we get to factoring, and the leading coefficient is 1, whenever this is the case, and you're going to see me do this throughout the video, we can go ahead and just write down a set of brackets like this, and we can go ahead and just put an x right there. All right, just put the x there, and now this is where the fun begins, and this is where your creativity, as Albert Einstein says, problem solving involves creativity. So our first step would be to write these two brackets. Our second step would be to write the x's right there in the first slot, if you will. And so now the third question is we come back over here to the c, and now what we want to do is ask, what are the factors of c that add up to the factor b? Okay, so what are the factors, oops, putting two words together there, what are the factors of c that add to b, to the letter b, not Shakespeare's to be or not to be. Okay, so the number c. So remember, factors, when we talk about factors are products of at least two different things. So you can have the factors of two numbers, 3 times 2, or you can have the factors of 27 being 3 times 3 times 3. So if you'll recall that at one point in time you took numbers and did what's called a prime factorization, where you tried to get it all the way down to like 2s and 3s and 5s. So we're just going to take a look at factors. So what two numbers multiply to 6? So notice that to get 6, we actually have 6 times 1 is 1 set. And don't forget the negatives. So we have to have -6, -1. And then we get another factors of 6. It'll be 3 and 2. And then we get -3, -2. So remember, we have to come up with all the factors. Okay. So when you get really used to this, and this is going to come up a lot in your college algebra course, along with the section 6.1 video that you just probably watched, factoring by grouping. Okay, and factoring out the greatest common factor. Factoring this, this, once you get used to doing this, it's going to come up a lot and a lot and a lot and a lot. It just kind of, you can start to do this pretty much in your head. So the question is, what are the factors of C? So now we have all the factors of the number. So now we have to add them up. So notice that these two add to 7. This is not the same as B, so this doesn't work. Notice that these add up to -7. -7 is not the same as 5, so these don't work. And 3 times 2 is 6. And notice that this adds up to 5. So there we go. We got this set, but let's just take a look at the last. -3, -2 is +6, but notice that this adds to -5. So this set here is not going to work. So the idea is that you do this until you find a set that works. And then all you do is these guys here, all right? So these guys here, this one goes in this slot, and this one goes in this slot. So now we get x plus 3 and x plus 2. Okay? So you can kind of think of this now as when we do this step right here, it becomes x plus, or x, and we have to be careful on the signs as we'll see later. Fill in the blank, x, fill in the blank. So it'll be either a plus or a minus. We'll see that later on. And again, just as I showed in the last video, you should never get these wrong because we can always verify. So let's verify. So if you don't recall, there's this FOIL method. So if we take a look at FOIL, FOIL says take the first terms in each of these over here. So the first terms is x times x, and notice that we get the x squared. And then the O is for the outside. So the outside is going to be the x and the 2. So we get the 2x. The inside is going to be the 3 and the x. So we get the 3x. And then finally the last, or the L, is for the last 2 terms. So we get the 3 and the 2, which is 6. So notice that this becomes x squared. So we can add these two up, gives us 5x. And then finally we get our last one. So we get 6. Okay? And notice that that's what we started with. So everything works out nicely. Okay, so that's going to be our game plan, if you will, working with these special types of polynomials. Okay, so we can take a look at this one here, which is x squared minus x plus 56. So we would like to take a look at a factorization of 56. And then here we got to be careful because notice it's got to add up to a negative. So we kind of got to be careful as to what we're taking a look at. So notice that 56 is 2 times 28. But notice that when we do the product, we got to end up with a positive. So notice that if I add these two together, I get 30. That's not going to work. But notice if I take a look at the negative of these, then I adds up to -30, and notice that this doesn't work. So we just keep marching down. The next one that I came up with was 4 and 14. So 4 and 14. So notice that 4 times 4 is 16. 4 plus 1 is 56. And again, we'll probably need to add these together, so we'll just do a double negative. So this product's to the 56, but this adds up to -18. So that's not going to work. So the next set that I came up with was -7 and -8. And again, I chose the negatives because this circled sign is negative. So notice that when I product 8 times 7, I do get my 56, but when I add, I end up getting my -15, which is not the middle term that we want. And notice that if I keep going, then it's going to be 8 times 7, but that repeats to this, and then the next one will be this, and the next one will be this. So notice that I can't come up with factors of 56 that will add up to a -1. So again, this does not factor to a product of factors, so I can come back and say that this polynomial is non-factorable, so it is prime. So let's take a look at x squared minus x minus 30. So again, I'll write down my double set of brackets, put an x, put an x. So now -30. So now I got to be able to come up with factors of -30. So let's just note that 30 is going to be 1 times -30. So notice that I product these two together, I get my -30, but when I add, I get -29. So that's not going to work. What about a -1 and a 30? Again, product these, I get my -30, but I add these and I get a +29. So these guys aren't going to work. So we'll just march down to the next set. So -2 and 15. And how about 2 and -15? So notice that these will multiply and both give me the -30. But when I add, notice here, I get 13. And notice here, I get -13. And I still need my -1. So that's not going to work. So another set here is going to be 3 and -10, or -3 and 10. That product gives me 30. But again, when I add, I get -7 and I get a +7. So those aren't going to work. So we can X all these out. So finally we're left with 5 and -6 and -5 and +6. So notice again, I product these together. They both give me the -30. I add 5 and -6 gives me a -1. So here we get pay dirt. And just for completeness, once you get pay dirt, you're done. But just for completeness, notice that when I add these together, I get a +1. So that's not going to work. So now I just come back over here and I go +5 and -6. And we are all done. Let's see. My next example is x squared plus 8x plus 9. So again, the factors of 9 is 9 and 1, 3 and 3. Can we kind of see that the factors that are going to add up to 9? Okay, so we take a look here. 3 and 3, so 9 plus 1 is 10. All right, so I put my, oh, I forgot to put my x there. Put some x's in there. What do you think? Does this any of these work? How about -9, -1, -3, -3? So none of these are going to work. So we can come back and say that this is prime. Okay. So how about x squared plus 7x minus 18? So again, we can write these out. X and x. So what are the factors of -18? So we got things like 18 and 1, 9 and 2, 3 and 6, and I think that's about it. So can we take a look here and let's see, what do we come up with? Since we have a negative, so it's going to be -9 and 2 or -2 and 9. So let's see, do these add up? So this one gives me my 7. We could take a look. Again, all you got to do is just find them. And once you find them, you're done. So -2 and +9. So again, we can verify our work. So notice we get x squared plus 9x minus 2x minus 18, which gives us what we started with. So again, x minus 2, x plus 9. And that'll get that one done. Let's take a look at what happens when we have two variables. Two variables. So we get a squared minus 7ab plus 12b squared. Well, when we have two variables, it's going to be kind of the same thing, all right, except a little bit of the same, a little bit of a tweak. So notice that for the a, I'm just going to put an a here and an a here, but notice I got this b squared. So why don't we just go ahead and throw in a b here. So now the question becomes, what are the factors of 12 that add up to -7? So notice that the factors of 12 is 12 and 1, 6 and 2, and 4 and 3. Okay, so we can get 12 and 1, that doesn't add to -7. 6 and 2, that doesn't add to -7. 4 and 3 does not add to -7, but these add to 7. What about -4 and -3? So here we get -7. So what if I put a -4 and a -3 in here? And again, first term's product, so I get my a squared. Okay, the outside term, so this times this, is -3ab. Inside terms, -4ab. And then my last terms, plus 12b squared. And notice that that gives me exactly what I started with. So we can go ahead and close that one out. Alright, so now we get x cubed y minus 6x squared y squared plus 5xy cubed. So this is kind of hooky, but let's just observe something that we have not done in the previous examples. And let's just notice in this one that we seem to have some common x terms going on, seem to have some common y terms going on. And notice that the numbers here, I got a 1, and then I got these guys here. So one of the things we can do here is just go ahead and factor our greatest common factor. So let's not forget that. And technically I should go back and ask on all of those other ones, was there a greatest common factor? But since it was in that particular form, we don't really have to ask that question. But here we got all kinds of craziness going on. So let's just take a look. It looks to me like I can pull an x out and a y out. So when I pull an x out, notice I get x squared minus 6xy plus 5y squared. And notice that this one, I have two variables, but notice that I have the double variable just like I did here. I've got a leading term of 1 and it's squared, and notice I have a number and a squared, a number and a squared. So that means that I can come over here, write down my xy, and I'm just going to write down double brackets, put an x here and a y here, an x here and a y here. And now I'm going to ask, what are the factors of 5 that add up to -6? Well, the only factors of 5 is 1 and 5 and -1, -5. And notice that this one doesn't work because it adds to 6, and this one does work. So I'm just going to go minus. I don't have to worry about putting the 1 here, and -5. So here we get a product of 3 terms. So one more example. This will be our final example. Kind of doing the same thing. So 4t to the 5th minus 28t to the 4th plus 48t cubed. So nice thing here, we got one variable. And let's just take a look. I got some numbers. It looks like I can pull a 4 out of each, is common in each. And it looks like I can pull out a t cubed. So notice I'm left with a t squared minus 7t plus looks like what, 12, and then we're done there. Okay, so notice this becomes what we've been working with at the beginning. All right, so now we're just going to go 4t cubed and then write our double brackets, put a t here. So now the question is, what are the factors of 12? So here we get 12, 1 and 12, -1, -12. That ain't going to work. And hopefully what you're going to see is that -4 and -3 at this point in time. Minus 4 minus 3 multiply to 12. So we get minus 4 and minus 3. And there is my complete factorization. Okay, so I got a product of terms. That's what we're after, a product of terms. All right, I hope this video helped you out. We'll see you in class. Bye.